Hey guys, welcome back to Helper Function. In this video, we will discuss another popular interview question, backspace string compare. So we are given with two strings s and t, and strings are in the form like this. Now this hash represents a backspace, which means that the character just before this hash will be deleted. So this original string will read as AD. Similarly, t is also kind of this. So this string will also read as AD. So we need to determine that whether s is equals to t or not. If it is true, then we will return true, otherwise we will return false. Suppose for example, let's say s is a, b, hash d and t is a, d, hash d. Then after removing all the backspace characters, this will become AD and this will also become AD. Thus, because these two are equal, we will return true. Now it is also given that after backspacing empty text, the text will remain empty. Let's say S is A hash hash B D. So there are two hash, which means that two characters should be deleted before this hash. But here we have only one character, so this string will read BD. Thus, if my T is A hash BD, then this will also read as BD, thus these two strings are equal. So let's see how we will solve this. Now the basic requirement to solve this problem is to get the original text, that is the text after removing the backspace character. Let's say we want to find the original text of a string S. Then we need to remove all the hash and the characters before the hash. So for this we can use a stack. Let's say we go through beginning and for every character we push that character in stack. Now whenever we get hash, we will do a pop operation in our stack. Thus the top element of the stack, that is the character that is just before the hash, will be removed. Let's try and solve by example. Let's say this is my stack. So I came across A, I will push A in my stack. Again I came across B, I will push B in my stack. Now I came across hash, thus I will pop the top element from my stack. Thus B gets deleted from stack. Now again I come across D, thus I will push D in my stack. Thus after end of the string, this stack will contain my original characters. And I will get that string by popping every element of the stack, and thus we will get AD as the original string. Similarly, we can find the original text for string T, and after that we will compare that. If S is equals to 3, we will return true, otherwise we will return false. So this approach requires order of n time complexity, but it also requires order of n space. That is, we are using stack to store the characters. We have another approach which can solve this problem in order of 1 space complexity. So let's see that. We will be using two pointer technique to solve this problem. One pointer will be I, that will be the normal loop pointer, and another pointer will be K, that will track the original text. So at the end of the loop, K will represent the length of the original text. The algorithm goes like this. We will be traversing through 0 to n minus 1. Now every time, if we get a hash, that is, if s of I is equals to hash, we will decrement our k by 1. Otherwise, we will assign s of I to s of k and increment our k by 1. Now we are doing this operation because if we have a hash, then we will not consider the character just before hash, and my k will get decremented by 1, and after that I get a character other than hash, then this character will come in place of the kth index where there is already a character but it has been deleted due to the hash. Let's try and understand with an example. So here at first my k is 0. I am at here a, and because a is not a hash, s of I will be assigned to s of k. Now because I and k are equal, it will have no effect and my k gets incremented to 1. The next character is b and it will have the same thing, and this time my k gets incremented to 2. Now we have a hash, which means that my k gets decremented by 1, thus my k is 1 now. This indicates that I have again come to this position, and after hash if I get a character, then this character will be assigned to position of k. Thus in the next step I get a d, and this time we will perform this operation s of k is s of I, and because k is 1, so s of 1 will now have d and k will become 2. Thus at the end of the loop the string will be something like this: a, d, hash and d. And because my k is 2, thus the original text is of 2 length. Thus this will be our original text. Similarly, we can find the original text for string t. Let's say it will have a pointer k dash. Thus the original text of string s will have length k and the original text of string t will have length k dash. So the minimum requirement for these strings to be equal should be k equals to k dash. Otherwise we will immediately return false. And now if k is equals to k dash, then we will compare these two strings till length k. If they are same, we will return true, otherwise we will return false. Now one more thing, that the minimum length of this k can be 0. Thus we will have to check that k is maximum of 0 or k. Now why we are doing this? Let's say we have a string like a hash hash b d. So because we have two hash function, so at this position s of I will be assigned to s of k and k will be 1. Now we have two hash, thus decrementing k, it will make k as -1. But it will have no effect as we have two hash but the character before hash is only 1. Thus one hash is useless and make k as 0. Thus we need to check for this statement. So this was all about the problem. The time complexity of this approach is order of n as we are using single loop, and the space complexity is order of 1 because we are using no extra space. Now let's quickly look at the code. We are given with two strings s and t. We declare two integer variables k1 and k2 initialized to 0. So k1 will have the original length of a string s and k2 will have the original length of a string t. We are doing the same thing as explained in the algorithm. If s of I is equals to hash, we decrement our pointer, and also we check that if my pointer is not negative. Otherwise, we assign s of I to s of k1 and k1 gets incremented by 1. Now we do similar kind of operation for string t as well, and after that we check that whether the length of k1 and k2 is same or not. If they are not same, then we will immediately return false as these two strings can never be equal. Otherwise, we go through this length and check that if s of I is always equals to t of I or not. If at any position they are not equal, then again we will return false. Otherwise, we will come out of this loop and return true. So this was all about the problem. I put the problem link in the description so you can go and solve it. If any doubts or suggestion, please write in the comment. Thank you so much for watching.